Good morning, everyone. I know after a long time we are back here, one of the session, our mathematics department, on behalf Bethlahem Matric and Higher Secondary School in Karungal. I am very happy to welcome all. So, in this conversation, we are going to discuss about Gauss-Jordan method concept and relative example and exercise. Okay, so one by one we'll see. So first one, what is the name of concept name? Gauss-Jordan method. Gauss-Jordan method. What is the meaning of Gauss-Jordan method? It is full and full depends upon elementary transformation method. So elementary transformation, the matrix form consider for A1, A2, A3, second row B1, B2, B3, third row C1, C2, C3. Okay, I have taken related example with the number also. Consider for 4, 3, 7, minus 1, 0, 8, 3, minus 1, 7. Okay, this is 3 into 3 matrix set, isn't it? 3 into 3 matrix set means the augmented term with the comparing I3. Why am I writing I3? Means this is 3 into 3 matrix set now. According to the questions, sometimes it will be changed. 2 into 2 matrix set means we have to convert here true. Okay, but here I have taken for the 3 into 3. That's why I wrote I3. What is the meaning of A? Augmented matrix. Augment matrix. So already you know what is the meaning of I3, 3 into 3 matrix set. I3 means 1, 0, 0, 0, 1, 0, 0, 0 and 1. That is called I3, 3 into 3 identity matrix. So look at their identity is actually the diagonal term, each and every value will be 1, isn't it? So here, how to comparing I3 means, so A I have considered for the number, okay, instead of letter I have written for number 4, 3, 7, minus 1, 0, 8, 3, minus 1, 7. Comparing I3 means identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. So, this is called A means this is called I3. So, concept of Gauss-Jordan, we will get it. This is a whole term I3 of form, that is identity form. So we need 3 important steps, then only we can find out here I3. How to apply that 3 important steps? So if you apply here some changes means definitely identity term also will be changed. Okay, identity when we will get it I3, this is we can say our final term of inverse, because according to the Gauss-Jordan method we need to find out inverse of the term. Okay, so listen very carefully. So what is the value of A1? 4, isn't it? So A1 is equal to 4 means according to the identity term, first leading diagonal we need to 1. So how to rearrange instead of 4 to apply the 1 means A1 each and every term divided by 4, then only 4 divided by 4 means here will come to the value 1. So entire the row, this first entire the row we have to do divided by 4. So divided by 4 means how to rearrange divided by 4 means, listen. So rearrange it, 4 divided by 4, what will happen? 1 will come. So here also 3 by 4 will come, then 7 by 4 will come. Important, here also some changes will come. So definitely here 1 by 4 will come, isn't it? So next last 2 times definitely we have 0 and 0. So what I am telling from this concept, we will get it definitely the diagonal term also will be 1, as well as remaining the part also we have to show here 0. So okay, A1 is clear. I am moving to second part. Second part means what is the meaning? Entire the row of 2, isn't it? Row 2 means what will happen? This is considered for B2, but we have B2 0 is there. If it's 0 means we have to interchange of row 2 and row 3. So how to rearrange First we have to rearrange. So row 2, row 3 means what will happen? Row 1 as it is. So we have divided by 4, another one result 1, 3 by 4 and 7 by 4, again 1 by 4, 0 and 0. So row 2 interchange row 3 means 3 minus 1 7, 3 minus 1 7, 0 0 1, 0 0 1. So row 2 minus 1 0 8, 0 1 0. This is called row 2 interchange row 3. So then the same condition, what we have to do? B2 we have to show 1. So B2 divided by show means definitely the B2 entire the row divided by minus 1. So divided by minus 1 means minus 1 divided by minus 1 means we will get it 1, isn't it? Then C3 also. C3 also the diagonal A1, B2, C3. C3 also we need 8. Then how to rearrange actually? So now C3 also we have to show 1, but we have here 7 is there. 7 means what you have to do? C3 divided by 7. So C3 divided by 7 means the entire the row we have to do divided by 7. Divided by 7. Then only we will get it. Here instead of 7 to divided by 7 means we will get it 1. So here divided by 7 1 means here also what we have to do? 1 by 7 will come. So that's why I am telling now, after getting the first part of identity, we will get some result in identity part. According to the identity term, we can say that our final term of our inverse. Okay, so this is our final answer. Okay, so I am moving to the question, so you will get it more idea. So let's start on example question. Okay, from this concept. So now I am moving to example 1.20. What is the question? Find the inverse of the non-singular matrix. A is equal to, this is definitely we can say 2 into 2 matrix, isn't it? So 2 into 2 matrix by Gauss-Jordan method. We need to find out inverse of the term, isn't it? So how to rearrange? First A with the compare I true. Already we know what is the name of A, augment matrix. So augment matrix means the original question. So what is the 2 into 2 matrix form? 0, 5, minus 1, 6. Then comparing I2 means 1, 0, 0 and 1. So I told you always the leading diagonal starting with the non-zero term. But here we have 0. What we have to do? So just we have to interchange. R1 interchange R2. What will happen? So R1 interchange R2. So listen very carefully. Minus 1, 6, 0, 1, 0, 5, 1 and 0. So after rearranging, starting with the leading diagonal always positive, that is 1, isn't it? Identity matrix means 1 starting. Here minus 1 is there. So we have to rearrange. R1 gives minus into R1. So minus into R1 means each and every time into minus means definitely here will come positive value. So look at there. So each and row 1 multiply with into R1. Minus into R1 means, so minus into minus 1. Again plus 6 means minus 6. Next condition 0 is there, minus 1 will come. Then second row as it is. What is the term? 0, 5, 1 and 0. So first diagonal, leading diagonal 1 is over. Then already we have under the term also 0. So listen very carefully. I just forget to in example basic concept. After getting the first part, under the 2 term also we have to show 0. Then only, because we know, isn't it, identity term starting with 1 means first row, first column 1, 0, 0. So under the 2 term we have to show 0. So here 0 is there. Okay, clear. Next diagonal we have the second term of 5 is there. We have to rearrange. R2 gives definitely 1 by 5 into R2. Each and every row into 2. What is the value? Multiply 1 by 5. So row 1 as it is 1, minus 6, 0, minus 1, 0. So 5 divided by 5 means 1 will come. Again 1 divided by 5, isn't it? So 1 divided by 5, then 0. Then here 1 is over, but we need here also 0, isn't it? According to the I2 matrix. So what we have to do? R1 gives R1, we need here 0, isn't it? So R1 gives R1 there minus sign is there. Minus sign means if you do plus means R1 plus 6 into R2. So look at there, very easy. So R1 plus 6 into R2, what will happen? R1, R2 as it is. R2, what is our term? 0, 1, then 1 by 5, 0. So R1 minus 6 plus R1 gives R1 plus 6 into R2. R1 is equal to 1 is there, 1 into 0, definitely value 6 into 0 means 0 will come. So 1 plus 0, value will be 1. First condition is 1. Second condition, minus 6 is there. So minus 6 plus, listen very carefully. So minus 6, then plus 6 into R2 value 1. 1 is there. So minus 6 plus 6, automatically value will be 0. Next condition, there 0 is there. 0 plus 6 into 1 by 5. So definitely 0 plus 6 by 5 will come. 6 by 5. Next term, minus 1 is there. Because R2 we have 0. So into 0 anything means value will be 0. So minus 1 plus 0 means value will be minus 1. Listen. So look at there. This is now I2 form. No, this is I2 form means this is we can called inverse of the term. This is our final term. Therefore, according to the Gauss-Jordan method, A inverse is equal to 6 by 5 minus 1, again 1 by 5, 0. Therefore, A inverse 1 by 5 take common outside means 1 by 5. Here 6 will come. There 1 will come, isn't it? Next one. Here minus 1 is there. Definitely minus 5 will come because 1 by 5 we have taken common outside. No. That's why I have written for minus 5. Here automatically 0. Okay. So this is our final answer. Okay. Inverse of the function. One of the important 2 more question. Okay. So please listen. If you have any doubts, please put in comment box. I am ready to clarify your doubts also. Okay. I am moving to next example 1.21. So solution. We need find the inverse of A. So given condition A is equal to 3 into 3 matrix set, true 1 1, 3 true 1, true 1 true. So the argumented term compare with I3 because the given condition 3 into 3 matrix set, isn't it? So I3 means true 1 1, 3 true 1, true 1 true. So I3 means 1 0 0, 0 1 0, 0 0 1. So now what we have to do? First always leading diagonal positive 1, isn't it? But we have the non-zero term, okay, but we have to show this is 1. What we have to do? R1 gives 1 by 2 into R1, isn't it? So 2 by 2 definitely 1 will come, no? That's why entire the row 1 we have to multiply into 1 by R2. So listen. Row 1 only, row 2, row 3 as it is. What is the row 2 actually? 3, true, 1, next true, 1, true, condition 0, 1, 0, 0, 0, 1. So listen very carefully, 2, 1, 1 is there. So true, 1, 1 is there means 2 by 2. 2 by 2 means value will be 1. Again here 1 by 2 will come, isn't it? So 1 by 2, here also 1 by 2. But first term of here also 1 by 2, 0, 0. So first condition is over. Next what we have to do, under the 2 term also we have to show 0. So under the 2 term we have to 0 means, so R2 gives R2 minus 3 into R1. Next condition, R3 gives R3 minus 2 into R1. So listen very carefully. So R1 as it is. What is R1? 1, 1 by 2, 1, 1 by 2, 1 by 2, then 1 by 2, 0, 0, 0, 0. So now R2 minus 3 into R1. So definitely 3 is there. R2 what is the value? So R2 we have 3, 3 minus 3 into R1. So 3 into R1. Next condition 2 minus again 3 into 1 by 2, isn't it? Next condition 1 minus 3 into 1 by 2. Here 0 is there, isn't it? So 0 minus 3 into 1 by 2. Here 1 minus 0 is there, so only 1 will come. So last term also, here also 0 into 0, 0 will come, isn't it? So here actually last two term 1 and 0, isn't it? They are actually 1 and 0. But here remaining the term 3 minus 0, 3 minus 3, 0 will come. Next listen there, 2 minus 3 by 2, isn't it? So 2 minus 3 by 2 means 2 into 2, 4, 4 minus 3. So 4 minus 3 means value will be 1. They are positive 1 by 2. Next condition 1 is there, minus 3 by 2. Cross multiply means 1 minus 3 by 2. So 1 into 2, 2 minus 3 means minus 1 will come. So minus 1 by 2. Here next condition only 0 is there. We can write it automatically minus 3 by 2. Row 3 what we have to do, 2 is there, isn't it? So 2 minus again 2 into row 1 means only 1. Same condition 1 minus 2 into 1 by 2. Next condition 2 minus 2 into 1 by 2. Here 0 minus 2 into 1 by 2. Here 0 and 0 no problem, but last condition also value will be 1 is there. So listen very carefully. Actually here there first 0 will come, next 1 will come, because there 0 value, here 1 value. Why? R3 and R1. R3 also 0, R1 also 0. That's why I wrote here 0. Next condition actually R3 is there. 1 minus there 0 values. So 1 minus anything means value will be 0. Remaining 2 minus 2 into 1, 2. So 2 minus 2 is equal to 0. Next condition 1 minus, listen, 1 minus 2 by 2 means value will be 1. So automatically value will be 0. Next condition 2 minus 2 by 2. So 2 minus 2 by 2 means 2 minus 1. Value will be positive 1. Next condition 0 minus 2 by 2. Value will be minus 1. Okay. Second term also over. Next. Here we need 1, isn't it? Because diagonal term we have to show 1. Opposite term remaining we have to show 0. So diagonal here 1 by 2 is there. What we have to do? R2 gives 2 into R2, isn't it? 2 into R2 means 1 by 2 into 2 means 2 to cancel, automatically value will be 1. So very listen, R1, R3 as it is. What is R1 value? 1, 1 by 2, 1 by 2. There, again 1 by 2, 0, 0. Next condition, R3 also as it is, 0, 0, 1, minus 1, 0, 1. R2, 2 into R2. So 2 into R2 means 0 is there. Here what will happen? 2 into R2. So 1 by 2 into 2. 2 to cancel means value will be 1. Next condition minus 1 by 2. So minus 1 by 2 into 2 means again 2 to cancel, minus 1 will come. Next condition minus 3 by 2. So minus 3 by 2 into 2 means again 2 to cancel, minus 3 will come. Here 1 into 2. So positive 2. Here 0 is there, 0. So next one. So here also 1 is there. So here we have to show 0. What we have to do? Look at there. Their center term 1 is there, isn't it? Center term 1 is there means R1 gives R1 minus there 1 by 2 is there. So R1 minus automatically 2 into R2, isn't it? So R1 minus here if you add 1 by 2 means value will. So R1 minus 2 into, otherwise R1 minus 1 by 2, isn't it? Yeah, 1 by 2 into R2. Check it there. We will get 0. Okay, listen very carefully. 1 by 2 into R2. We will get it 0. How? R1 only, isn't it? So I will rub here. So R1 gives R1 minus 1 by 2 into R2. What will happen? R1 minus R2 R3 as it is. Listen very carefully. R2 R3. 0, 1, minus 1. Then minus 3. 2, 0, then R3 also 0, 0, 1, then minus 1, 0, 1, isn't it? So here R1 minus 1 by 2 into R2. They are definitely comparing 1 and R2 means 0 is there. So 1 minus 0, 1 will come. Here listen there, R1 minus, R1 value 1 by 2 minus, there 1 is there, no? So 1 by 2 minus 1 by 2 means value will be 0. 1 by 2 into 1 means 1 by 2. So 1 by 2 cancel means there what the value will come? 0. So next condition, look at there, here also again R1 minus. So R1 minus means there R1. R1 value 1 by 2 minus again 1 by 2 into R2 means minus 1 is there, isn't it? So minus 1 means again 1 by 2 plus 1 by 2 will come. So 1 by 2 plus 1 by 2 means value will be positive 1, isn't it? So condition, next condition we have to look at very carefully because there is a opposite term, no? 1 by 2 is there, R1 only change, isn't it? R1 value, so 1 by 2 is there, minus again 1 by 2 into minus 3, isn't it? So minus 3 means 1 by 2 minus into minus plus 3 by 2. Again 1 plus 3 means 4 by 2. Value will be true. So here value will be true. Next condition, R1 comparing minus 1 by 2 into 2 is there. So R1 0 is there. Listen. 0 minus again 1 by 2 there R2 value true. 2 to cancel means value will be minus 1. Last condition comparing 0, R1 R2 we have only 0. So output also 0. Okay. Now next condition. So now diagonal we have proved 1. So third column. So third column first 2 times we have to do 0. What we have to do? Comparing. So R1 we have to 0. What we have to do? R1 minus R3 means will be 0, no? R1 minus R3. Next term, there minus is there. So minus means R2 gives R2 plus R3 because minus 1 plus 1 means will be 0. That's why I have written for positive sign. Okay. So listen, I am moving to last step. R1 and R2. R3 as it is 0, 0, 1. Then minus 1, 0, 1. R1 minus R3. So R1 minus 1 minus 0, 1. 0 minus 0, 0. 1 minus 1, 0. Here also very carefully because minus in center. So there already minus sign is there. So 2 minus of minus 1. Automatically minus into minus plus. So 2 plus 1 value will be 3. Next condition. There minus 1, 0 is there. Automatically minus 1. There 0 and minus 1 is there. So minus 1 will come. Then next condition. Second row. R2 plus R3. 0 plus 0, 0, 1 plus 0, 1, minus 1 plus 1, 0, minus 3, minus 1, minus 4, 2 plus 0, true, 0 plus 1, 1. So now look at there. Now we can say this is called I3 means definitely we can say this is called A inverse. Therefore, A inverse is equal to, so A inverse is equal to 3 minus 1 minus 1 minus 4 true positive 1 minus 1 0 and 1. This is our final term of inverse for example 1.21. Okay. So please listen my dear students. I am moving to exercise 1.2 question number 3 subdivision 2. Okay. So I would like to recall only one question from exercise. So remaining problem try to do yourself. So no problem, I am always with you. So if you have any doubt put in comment box, definitely I am clarify your doubts. Okay. So what is the question? Find the inverse of A is equal to 3 into 3 matrix that is there by Gauss-Jordan method. Okay. So Gauss-Jordan method. So A is equal to 1 minus 1 0 1 0 minus 1 6 minus 2 and minus 3. Then we have to compare the augmented matrix with I3. So I3 means 1 minus 1 0 1 0 minus 1 6 minus 2 minus 3. Augmented term I3 means 1 0 0 0 1 0 0 0 1. So look at there. First already we have original question, original term also we have the leading diagonal positive 1. So under the 2 term only we need to 0. So what we have to do? R2 gives R2 minus R1. So because 1 minus 1 automatically value will be 0. As well as R3 gives R3 minus 6 into R1. So 6 into R1. But R1 as it is, isn't it? So what is R1 term? 1 minus 1 0, 1 minus 1 0, then 1 0 0, 1 0 0. Listen very carefully. R2 minus, so 1 minus 1 0. 0 already common minuses, so minus into minus plus 0 plus 1 means a positive 1. Again minus 1, there 0 is, so directly minus 1. Next condition 0 minus 1, so minus 1. 1 minus 0, 1, 0 minus 0, 0. R3, listen very carefully, R3 means R3 minus 6 into R1, so 6 minus, again 6 into R1 means only 1 is there. Same condition, 0, here minus 2, isn't it? So minus 2 minus 6 into R1 means only minus 1. Here minus 3 is there. So minus 3 minus 6 into there 0. Here 0 and comparing 1. But we have minus 6 into. So 0 minus 6 into 1. Next condition 0 and 0, no need. Again here 1 is there, isn't it? But here we have 0, isn't it? 0 and 1 will come. So definitely here 0 will come, the last and term will be 1 will come, isn't it? Remaining the term, look at there, 6 minus 6 into 1, 6. So 6 minus 6 is equal to value will be 0. Next one, minus 2, minus into minus, positive 6. So minus 2 plus 6, value will be positive 4. Next condition, minus 3, only minus 3 will come. Remaining 0 minus 6, so value will be minus 6, isn't it? Now, next term. So here also 1, diagonal second term also 1. So under the 2 term we have to 0. What we have to do? Here definitely very easy, no? So R2 gives, sorry, my R1 we need. See here we can write it, R1 gives R1 plus R2. So definitely minus 1 plus 1 means value will be 0. R3 gives R3 minus 4 into R2, because R2 we have 1 is there. So 1 into 4 means 4. Therefore, R3 value already we have 4. 4 minus 4 is equal to value will be 0. Okay. Listen very carefully. Second row as it is. What is the second row? 0, 1, minus 1. Then minus 1, 1, 0. 0. Next, listen very carefully. R1 plus R2. 1 plus 0. 1. Minus 1 plus 1. 0. 0 minus 1. Minus 1. 1, already we have plus sign, isn't it? So 1 minus 1, value will be 0. There 0 plus 1, value will be 1. 0 plus 0, 0. R3, look at there, R3 minus 4 into R2. There 0 is there. So 0 minus 4 into R2 value 0. Next condition, 4 is there. 4 minus 4 into R2 value 1. Next, minus 3 is there. Minus 4 into value will be minus 1. Next term, minus 6 minus 4 into minus 1. Next condition, 0 minus 4 into 1 is there. Last condition, 1 minus 4 into 0 is there. So listen very carefully, 0 minus 4 into 0, 0 will come. So 0. Next one, 4 minus 4 into 1, 4. 4 minus 4 is equal to 0. There minus 3 is there. Listen very carefully. So here actually minus 3 and plus 4 will come, isn't it? So minus 3 and plus 4 means value will be 1. Next condition, here minus 6, isn't it? So minus into minus, positive 4. So minus 6, positive 4. So minus 2. Next one, 0 minus 4. Minus 4. 1, 4 into 0, 0. Therefore 1 minus 0 means 1 is there. Next what we have to do? Next step. There under the term, isn't it? Very simple, no? We have to show 0. R1 gives R1 plus R3, isn't it? R1 plus R3, as well as R2 gives R2 plus R3. So listen very carefully. R1, R2, R3 same. What is the term actually? 0, 0, 1, then minus 2, minus 4, positive 1. R1 plus R3, 1 plus 0, 1, 0 plus 0, 0, minus 1 plus 1, 0, 0, minus 2, minus 2. There 1, listen very carefully, R1 plus R3, 1 minus 4, minus 3, then 0 plus 1, positive 1. Next one, R2 plus R3. R2 plus R3 means 0 plus 0, 0. 1 plus 0, 1. Minus 1 plus 1, 0. Minus 1, minus 2, minus 3. Again 1 minus 4, minus 3. Again 0 plus 1, 1. So now look at there, this is we can call I3. This is we have to show I3 means this is called A inverse. Therefore, final term of A inverse, we need to find the inverse, no? So A inverse is equal to minus 2, minus 3, positive 1. Then minus 3, positive 1. So minus 2, minus 4, positive 1. So this is our final term of inverse for exercise 1.2, question number 3, subdivision 2. So matrix inversion method, very simple. This is already we have learned in the matrix method. So simple concept, matrix inversion, consider the normal matrix equation. What is the form? Capital AX is equal to B means how to find out from this equation, capital X, A bring out opposite sign means A inverse. So A inverse into B. So already you know how to find out the inverse of the function. Already we have discussed so many example, even exercise also. So how to find out the A inverse? So 1 by determinant of A into adjoint of A. Always determinant of A, it's not equal to 0, isn't it? That is a condition. It's a matrix inversion, one of the important 3 or 5 mark also. So you have to alert, okay? So one example question. What is the question? Example 1.22. Solve the following, the system of linear equation using matrix inversion method. They are given 2 equations. First we have to arrange capital AX is equal to B. So capital AX is equal to B means A is equal to 2 into 2 matrix set. The first row 5 and 2, second row 3 and 2 into X means X and Y. Then B means constant 3 and 5, isn't it? So now how to find out the, because we need matrix inverse, how to find out the inverse, how to find out the capital X? Capital X means A inverse into B. So A inverse into B means this is considered for A, this is considered for capital X, this is considered for B means X is equal to A inverse. A inverse means X, what is the value? X and Y. Then A inverse means 5, 2, 3 and 2, then inverse into B. B means a constant 3 and 5, isn't it? Now how to find out the inverse? 1 by determinant of A into adjoint of A. First we need to find out this is the term, inverse of the term. So inverse of the term means A inverse, how to find out? 1 by determinant of A into adjoint of A. So how to find out the determinant of A? AD minus BC. So AD minus BC means 5 into 2, 10. Cross multiply 3 into 2 means 6. So 10 minus 6 is equal to 4. Definitely we can say it's not equal to 0. Then how to find out the adjoint of A? So 2 into 2 matrix set means very easy. Interchanging the leading diagonal. Interchanging the leading diagonal means, so 2 and 5, change the sign of off diagonal. Minus 2 and minus 3. This is adjoint of A. Then just we have to apply the formula, inverse of the formula. A inverse is equal to 1 by determinant of A is equal to 1 by 4. Then adjoint of A, 2, minus 3 and positive 5, isn't it? Minus 3 and positive 5. Then how to apply now? So A inverse, so X and Y, inverse of the function we found 1 by 4 into, then 2, minus 3 and positive 5 into constant, isn't it? Into B. B means constant. So 3 and 5. What we have to do? So 1 by 4, first row multiply with the second set of corresponding column, second set of first column. So 2 into 3, 6. Again minus 2 into 5, minus 10. Next condition, minus 3 into 3, minus 9. 5 into 5, positive 25. Therefore, again outside constant 1 by 4. 6 minus 10, minus 4. Minus 9 plus 25, positive 16. This is called actually x and y. Therefore, x and y, so definitely each and every time divided by 4. So minus 4 by 4. Minus 4 by 4. Again 16 by 4. So look at there. So x and y is equal to minus 4 by 4 means minus 1. 16 by 4 means a positive 4. Therefore, the solution x is equal to minus 1, y is equal to positive 4. This is the final answer for x and y. I am moving to next example 1.23, one of the important 5-mark questions. So this is also matrix inversion method. Already we know what is the basic. Consider the matrix equation means capital Ax is equal to B means how to find out the capital X, A inverse into B. So what is the meaning of inverse? We have discussed so many problems. So 1 by determinant of A into adjoint of A. So listen very carefully. First we have to arrange capital Ax is equal to B. What is the meaning of capital A? True, 3, 3. Next 1 minus 2 positive 1. 1 minus 2 positive 1. 3 minus 1 minus 2. 3 minus 1 minus 2. Then x means x1, x2 and x3. Then B means constant 5 minus 4 positive 3. 5 minus 4 and positive 3. So what we have to do? First need to find out A inverse. So A inverse means, what is the meaning? A inverse means 1 by determinant of A into adjoint of A. So 2 into 2 means very simple. Directly AD minus BC is equal to 0 means the determinant A we found. But 3 into 3, first we have to suitable the value. Suitable means signs conversion method, plus minus plus. So first we need to find out determinant of A. So determinant of A means signs conversion, plus minus plus. What will happen? So 2 into minus 2 into minus 2, positive 4. Cross multiply means minus 1 into 1 minus 1. Whenever cross multiply, extra minus will be added. That's why plus 1. Next one, minus 3 into 1 into minus 2 minus 2. Cross multiply 3 into 1 means minus 3. Last one, positive 3. 1 into minus 1 minus 1. Again cross multiply 3 into minus 2 minus 6. Extra minus will be added whenever cross multiply. So positive 6. Therefore, so 2 into 4 plus 1 5 minus 3 into, first minus 3 outside, again minus 2 minus 3 means minus 5. Next one, plus 3 into minus 1 plus 6. So positive 5. Therefore, determinant of A is equal to 2 into 5 means 10. Minus 3 into minus 5 means positive 15. Again 3 into 5 means positive 15. Therefore, determinant of A is equal to 15 plus 15, 30. 30 plus 10 is equal to 40, isn't it? So determinant A is over. Then what we have to find out? Adjoint of A. What is the meaning of adjoint of A? So adjoint of A means transpose of cofactor matrix. Transpose of cofactor matrix. First you have to arrange it in cofactor matrix form. So cofactor matrix form. So cofactor matrix, how to arrange it actually? So cofactor matrix. Cofactor matrix means signs conversion, plus minus plus, again minus plus minus, again plus minus plus. First we have to select the signs conversion positive sign. If you skip row and column of 2 means minus 2 into minus 2, positive 4. Cross multiply minus 1 into 1, minus 1. Cross multiply means positive 1. Then next signs conversion minus. Minus means 1 into minus 2, minus 2. Cross multiply 3 into 1, minus 3. Last one, signs conversion plus sign. So 1 into minus 1, minus 1. Cross multiply 3 into minus 2 means minus 6. Cross multiply means positive 6 will come. So second row of row minus, isn't it? So minus means Again, if you skip row and column of 1 means 3 into minus 2, minus 6. Minus 1 into 3 means minus 3. Sorry, my dear, this is positive 3, because cross multiply. Minus 1 into 3 means minus 3. Cross multiply means extra minus will be added. That's why minus into minus plus. Next one, plus condition. Listen very carefully. Again, if you skip row and column of minus 2 means 2 into minus 2, minus 4. Again, cross multiply 3 into 3, 9. So, minus 9 will come. Next one, signs conversion minus. Minus means if you skip row and column of 1 means 2 into minus 1, minus 2. Cross multiply 3 into 3, minus 9. Again, last term. So, plus sign means 3 into 1, 3. Cross multiply means minus 2 into 3, minus 6. Positive 6 will come. Next condition, there signs conversion minus. Again, if you skip row and column of 1 means, listen very carefully, 2 into 1, 2. Cross multiply means 1 into 3, minus 3. Last term, plus sign. 2 into minus 2, minus 4. Cross multiply means 1 into 3, 3. Extra minus will be added. So, minus 3 will come. So, listen. B value we need 5 minus 4 and 3. What is the B value? 5 minus 4 and positive 3, isn't it? So again, plus sign is there. 4 plus 1, 5. Outside also plus sign. So positive 5. Here minus 2, minus 3, minus 5. Outside common minus is there. Positive 5. Minus 1 plus 6. Positive 5. Outside also positive 5. So 5. Second row, minus 6 plus 3 means minus 3. Outside common minus is there. So positive 3. Minus 4, minus 9, minus 13. So next line, minus 2, minus 9, minus 11. Outside common minus is there. Positive 11. Again 6 plus 3, 9. Here 2 minus 3, minus 1. Outside common minus, positive 1. Minus 4, minus 3, minus 7. This is actually cofactor matrix. What is the meaning? The cofactor. Then how to find out the adjoint of a transpose of cofactor matrix? So what is the meaning of transpose? Row should be right column wise, column you should be right row. That is called transpose matrix, isn't it? So cofactor matrix. So cofactor matrix, we need to find adjoint of A. Adjoint of A means row means 5, 5, 5, again 3, minus 13, positive 11, 9, 1, minus 7. This is called adjoint of A. Now we found determinant of A and adjoint of A. Then how to find out inverse? 1 by determinant of A into adjoint of A. So 1 by determinant of A into adjoint of A means determinant A value 40, isn't it? So determinant A value 40. Again, A inverse means 1 by 40 into adjoint of A. First row, first column 5, 5, 5. Second column 3, minus 13, positive 11. Third 9, 1, minus 7. So listen very carefully. This is A inverse. First, what is the formula actually? Capital X is equal to A inverse into B. Capital X means x1, x2 and x3. Then A inverse means 1 by 40 into 5, 3, 9, 5, minus 13, positive 1, 5, 11, minus 7 into B is equal to 5 minus 4, 3. 5 minus 4, 3. Now, so listen very carefully, the last line. First line, x1, x2 and x3. x3 is equal to 1 by 40 into, so 5 into 5, 25. 3 into minus 4, minus 12. 9 into 3, positive 27. Second row, 5 into 5, 25. minus 13 into 4. Minus 13 into 4 means definitely positive. 13 into 4 means 3 4s are 12. 40 plus 12 is equal to 52. Next condition, 1 into 3, 3 isn't it? Third row, 5 into 5, 25. 11 into minus 4, minus 44. Minus 7 into 3, minus 21. Listen, so 1 by 40, 25 plus 27, 52. 52 minus 12 means 40 will come. Here 25 plus 3, 28. 28 plus 52 means positive 80. Last line, minus 44, minus 21, minus 65. Minus 65 plus 25 means minus 40. Therefore, definitely we can say 40 divided by 40 means x1 value 1 will come, as well as y1 value 80 divided by 40 true will come. The last one, sorry maybe this is x2, isn't it? So x2 value 2 will come. Then x3 is equal to minus 40 divided by minus 40, minus 1 will come. Okay dear, so in this conversation I hope you understand everything. If you have any doubt, please put in comment box. I am ready to clarify your doubts. Okay, thanks to viewers. I will continue the next session. Bye bye.